Welcome to this presentation. It is about developing TDD applications with JUnit 5. And we are going to spend some time together to discuss about the main challenges, main ideas and main challenges that TDD approach of the developing of the application means, and how we can make the step to JUnit 5. I presume that some of you may have at least some basic understanding of TDD. Probably some of you have worked at least with JUnit 4. We are going to present the main ideas behind TDD and to make, as we're saying, the step to between the JUnit 4 and JUnit 5. So here we see the objectives of our workshop. You should expect that at the end of our presentation and at the end of our workshop, you will be able to understand the fundamentals of unit testing. Then the basics of JUnit 5, its architectures, its main features that come besides the ones that were already provided by JUnit 4. The basics of TDD or test-driven development, and we'll show some demonstration in order that you understand how to develop a JUnit 5 TDD application. Who should attend this workshop? Who are the main targets of our presentations? If you are a Java developer, you are new to unit testing, but you have some good understanding of the Java programming language, then yes, it is for you. Also, if you are a developer and you have developed using JUnit 4 and you want to learn and to use the new features of JUnit 5, then yes, also it is for you. And also, you may attend as a tester that needs to automate some part of the activity. And working TDD, understanding TDD and the work with JUnit may be of good help for supporting and for testing the application. So, a natural question that arises is, what is JUnit? JUnit is a framework, and in particular is a unit testing framework for the Java programming language. It has some relatives that are collectively known as XUnit. The first one was SUnit, and the first versions of JUnit were presented as some jar, Java archive, that was linked to the applications at compile time and then used at runtime. Having such a framework is, of course, very important in the approach of the test-driven development, and it is for sure the most commonly included external library in Java projects. So it does not belong to the JDK, it does not belong to the Java development kit, but it is an external library, and for sure it is the most commonly used one. How did this start? This has started by two very important people into the Java community. They are Ken Beck and Erich Gamma. They had some discussions about how to develop safe applications, how to make some automatic testing. And there is some story that was saying that they had some discussion and they have moved to a plane because they needed to fly for a longer flight. And into the plane, they have started working on this first version of JUnit. That was pretty many years ago. And we say and emphasize that it is indisputably the single most important third-party Java library that has ever been developed. We have here a quote from Martin Fowler, which is also a very important person into the Java community. It says that never in the field of software development was so much owed by so many to so few lines of code. In fact, this is something that takes the idea that has been promoted by Winston Churchill during the World War II, when he was saying that during the flight attacks against Great Britain, he had a speech saying that never in the history of human conflict was not so much used by so many to so few. The few were the ones from that were defending Great Britain. Coming back to Martin Fowler and to what he has said, the essence is that it is a very, very useful tool. It is not so big, it has few lines of code, but working TDD with JUnit 5 is for sure of great benefit. So it is a lot owed to very few lines of code. Now about the idea of test-driven development. That is a more general idea, and JUnit is one possible framework that is supporting this test-driven development. Test-driven development is a software development process, but it is different than the old classical development process in the sense that it starts with some very short development cycle in mind. It says, I would like first to see the requirements, what it is expected. We are turning the requirements into specific test cases. Then we would like to improve our software in order to pass only the new tests. So we say we have to do this, and then we write the code that is making these new tests that have been introduced to pass. The previous approach opposed to this TDD was the software development that was allowing software to be added no matter if it was able to prove or not the requirements that it was built for. So you see that this is very important. We have some requirements in mind, we are defining these requirements, and then we are writing the code that makes these requirements pass. Which are the TDD benefits? And this is a natural question if you come and say, why should I work TDD? Why shouldn't I keep my usual old style of developing applications? First, you are driven, as test driven, you are driven by clear goals. Why? Because your tests will capture what needs to do, what needs to be done. You say you have to do this, and you write a test that checks that this happens. And then you write the code that is making the test fixed. So you are driven by the clear goals. You have to do this and this. The code is safer. Why? Because we have these automatic tests. And when we write our code, our new code, we will make sure that we are addressing the test and the test will pass. The code is also safely developed because if you introduce some new functionality, you would like, of course, not to touch, not to affect in any way the already existing code that you know that it is working well. What may happen in some other approach if you write some code and you break some already good existing and good working functionality? It is not nice, and these things are known as regressions. But if you have some tests that check and make sure that you don't touch the old functionality, introducing new features will also be much safer. Then you are able to isolate the incorrect code. It means that if something goes wrong, you are going to see which test is failing. Say, I try to do this, and I am expecting some output, and instead of the expected output, I am getting something else. So you are warned by the test that the output is different than the expected one, and it will tell you exactly where it happens. It will isolate the incorrect code. You will be able to easily introduce new functionality, both because you are driven by the tests, so you know exactly what to address, and also, as we are saying, because we make sure that we don't touch the old well-running functionality. And last but not least, it documents the application. Why are we saying this? We're saying this because when you run some application, you would like to see what happens, what is the goal of that application, what it is doing. If you take a look at the tests, you will understand that you have some input, some output, so you will understand much easier what is as input and what is expected the application to provide as output. Now, we would like to address a general question. You were working on application and you come and say, is my application doing what it is supposed to do? Or somebody comes to ask you, is your application doing exactly what it is supposed to do? What you may say, and most importantly, how can you justify such an answer? Say yes, no. If you have some application that has been in use for some time and it has been manually tested by different users, you may have some certainty that it is working the expected way. But of course, it is a matter of time, and time is extremely precious, especially today. How may I test my application? How much time will be needed to test my application, and how many people may be involved to do the testing? We may have some dedicated testers in our team. We may provide the application to the end users, and they may work for some time, but this takes time. And if there are failures, this may be very unpleasant. So how can we shorten this verification of the fact that our application is doing what it is supposed to do? Test-driven development and JUnit come in action now. We're saying that it relies on the idea of having the tests that check the already existing functionality. If you come and introduce some new features, then you have the possibility to check from the beginning what these new features are supposed to do and to make the old code untouched, the old functionality, in fact. So instead of spending weeks, months until the verification process is fulfilled, instead of relying heavily on the testers' teams and on the end users, we may have at least some basic and partial verification provided by the unit testing. Why do we need these tests? What they provide? They provide, first of all, fast feedback. So they will tell you really quickly, this works, this does not work, and not only that it does not work, it will tell you more exactly what does not work. And fast, this is fast. Usually you run the test within a few minutes. Then the code is easy to refactor and to modify. Refactoring means changing the internal structure of an application without changing its functionality. What it is about, you may think about the situation when you add new functionalities and new functionalities to the existing application, to the existing code, and you consider at some time that you can improve the design, the internal design of your code. Then you do what it is called refactoring. It means that you change the design during the development of the application, but you would like to keep the functionality. You would like the functionality to be untouched. What can support you in order to make the functionality untouched? Of course, unit testing. You do refactoring or you do modification, you have this safety that you don't touch the already existing and working functionalities. If the code is easily testable, this also means better design. It is easier to be understood. You see the test in action and you understand what the application it is supposed to do, and you have some basic understanding, at least some basic understanding of the design. And as we're saying before, test also document the application. You look at them and you have some documentation about input, output, what it is supposed to do. Now, if you would like to think about the code production lifecycle, how we're doing this without TDD, without any unit testing framework. You write the code, spend some time on it, then you do some testing, some manual testing in the sense that you introduce some input, you take a look at the output, and eventually you try to fix what it seems that does not work well. You have to debug. And then again, write code, test, debug. This is a pretty boring and inefficient way to work. And as we're saying, you may write some code that you fix, test manually, look at the input and output, everything is nice, but you are in fact affecting some other functionality. You have some side effects. This was the code production lifecycle without TDD. Among the benefits that TDD are providing, we say that it is isolating the incorrect code. What does it mean? So if there is something that goes wrong, you will detect it much, much faster than by doing some manual testing, and you do not know when you are going to do it, and you do not know how much it will require, how much time it will require from your side. If you have some incorrect code and you would like to go some wrong way, somebody will stop you. Who will stop you and who will tell you that you shouldn't go that way? Of course, there are the unit tests. They will tell you the code is not working properly, it has to do that, it has to obtain that, but in fact, it is doing some other thing. So you will be able to quickly isolate the incorrect code and immediately take a look what's happening here and think about what you have to do in order to fix it. Also, it is very useful to work TDD for introducing new functionality, because usually the developer is facing some task to implement this and that, and you take a look and try to understand first what needs to be implemented. What is this task about? If you have some tests that already tell you, if you have this input, you have to get this output, and if you have this other one input, it must work this way, then you will have already the understanding of the new functionality. You are, as TDD says, driven by the tests, driven by your goals. Where do you have to arrive? You have to arrive to make some functionality to pass some tests. And not only this, if you are driven by the test, you will understand that you have to do to write some code in order to make the test pass. So you will be focused on these goals. The goals to implement the correctly working application. And we're saying that working TDD also comes with the benefit of documenting the application. Why are we saying this? Of course, you arrive to some new application, you join a new project, there are probably experienced people there, they know much better what it is happening, and you would like to understand. You may spend some time discussing with them, but it is not always comfortable because, of course, you are taking from their time. You may read documentation and read documentation, and of course, this documentation had to be written at some time by somebody. Or you may arrive to the need of writing the documentation for exactly what you have implemented. This is a tedious process. Both reading and writing documentation is a boring and tedious process, and most developers do not like to do it. But if you have the test, you have the test that you can run, and you can follow the test. And they're saying, I receive as input this and this, and I do this process, and I need to get this result. This will be part of the application documentation. So we're not saying that the tests are fully replacing the documentation, but they are a very important part of the documentation. And we have here the test pyramid. So we're saying that in some old approach, focus was on the manual testing. Either if you have your own testing team, or if you rely at least partially on the feedback from the end users, most of the testing was done manually. Now, looking at this pyramid, we see that at the ground of this pyramid, we have these unit tests. Unit, why is it called, you may ask, why is it called unit test? What's a unit? A unit is in fact a method or a class, and you focus on testing something small. You focus on testing a class or a method. That's why we call unit testing. Of course, that will not fully solve the whole entire testing process, but it will solve here, as we see from this picture, the ground, the very basic, the first step. And as the picture shows, this is the foundation of the pyramid. Everything is relying on this foundation. So this is the first thing to make. Of course, it does not fully replace the idea of testing components, integration testing, system testing, and some end manual testing, but it provides a solid foundation. It takes the hard burden of the whole pyramid, and it is supporting all other processes of testing. Now we take a look at JUnit. JUnit, as we were saying, it is a framework designed for TDD. It is designed for TDD with Java, and version 4, which has been very popular, has been very widely spread. It still comes with some problems. Why were people still not so happy with, they were happy, but not so happy as they should have been with the JUnit 4 architecture and with the JUnit 4 functionality. So it was heavily used, it was providing really good benefits. However, it was still hiding some some problems. First of all, as our picture shows, it is providing a single jar file. So it was really monolithic. Everything was concentrated on there, and you know, when it is monolithic, it is harder to change. Then we say that it had no flexible API. So the designers of the JUnit up to version 4 thought about providing to the developers some good API, but as the JUnit was very popular, it needed to be integrated with a lot of tools, most importantly with the IDEs. So there was some need for integration between JUnit 4 and Eclipse. There was some need for integration between JUnit 4 and IntelliJ, and many other tools. So the fact that the JUnit 4 was indeed really popular was a great fact. But the bad side of this was that it was not providing an API that would have allowed the IDE to interact with JUnit. Oh, that's bad. How can the designers of the IDEs, of the plugins of the IDEs, work with JUnit? They needed to get into the internals of the JUnit. They needed to use mostly reflection in order to get some information that was really needed in order to make the tests running from the IDE, Eclipse, IntelliJ, or some other IDE. This was dangerous. Dangerous, at least in the idea of the fact that if you get into internals of some classes, you are breaking the encapsulation. And if you are using reflection, you get a very powerful tool, but the original designers of the JUnit had very little things to do. So they, for example, they couldn't even change the name of some private variable or some private method, because it would have broken the functionality of the plugins that work with the IDE. So the great popularity of JUnit was in fact a great disadvantage. Everyone intended to work with JUnit, and consequently it was breaking inside the internals. What was the solution? The solution was to make the step and not to allow getting into the internals, but to provide an API that will allow the IDEs to work with this. We're saying now everyone will be able to use this JUnit. The developers will continue to work with the JUnit from the side of the developers, but also the designers of the IDEs and the IDEs plugin will be able to use the JUnit through the API and not through the reflection, and not to break the encapsulation. Okay, we are making the step towards JUnit 5. As we're just saying, one of the disadvantages was the fact that it was providing monolithic approach. Now, one of the ideas was to go to the modular approach of JUnit 5. So the modular approach of JUnit 5 included separation of concerns. One API to write the tests that was already existing, and it was somehow changed and improved. But also very important, mechanisms to discover and run the tests, and the API to run tests from the IDEs and tools. Exactly what we were just talking. and exactly what it was missing and what it was generating those hard problems that we have presented. So into this modular approach, now we have really a separation of concerns. Okay, which are the modules of JUnit 5? We said that it is a modular approach, so it means that it really should provide some modules. First module is called JUnit Platform. This is designed in order to allow developers to write tests. This is similar to what we were to find in JUnit 4. Of course, we have some changes, we have some improvements, we have these differences at the level of the API, but when we talk about JUnit Platform, we only talk about the API that is handled to the developers, the ones that are writing the tests. JUnit Jupyter, here is the big change. Here is the API that is able to work with the tools, the API that is able to work with the IDEs, with the CLIs. You may ask yourself, why Jupyter? Where does it come from? The answer is simple. Jupyter is the 5th planet of our solar system, and besides this, it is the largest one. So the designers have considered that this big step towards JUnit 5 should be best illustrated by choosing the name of Jupyter. And the third module is JUnit Vintage. Of course, we need to keep some backwards compatibility. What are we doing with JUnit 3? What are we doing with JUnit 4? We don't have to forget them, and we have to provide some support. Always backwards compatibility is important, and this comes here with JUnit 5 into the module of JUnit 5 Vintage. So we have now a first image of JUnit 5 versus JUnit 4. What we have to understand from the beginning is that JUnit 5 came with different philosophy, with different architecture. JUnit 5 has broken the monolithic idea, keeping what it was working. Just a moment. Keeping what it was working, it makes some really big changes into the architecture. But of course, there are some changes into the API. And if we put this architecture, if we consider that we have understand the main changes into the architecture, we may ask ourselves, what do we need in order to run a program, to develop an application with JUnit? The answer is, for JUnit 4, you needed Java 5 or higher. For JUnit 5, you need Java 8 or higher. So these are the requirements. JUnit 5 works starting from Java 8. Changes at the level of the API. Of course, they have been introduced. And we see here some face-to-face annotations. Some annotations that mainly do the same thing, but have different names. For example, before class and after class from JUnit 4 are now before all and after all in JUnit 5. Before and after from JUnit 4 are now before each and after each in JUnit 5. Ignore from JUnit 4 is now disabled in JUnit 5. Is it just some naming changes? Why has it been done? And what was the reason behind it? the old names were not good enough? No, the answer is that is not a cosmetic change of the names. The idea is to allow a smooth passage from JUnit 4 and JUnit 5. And if we provide different names, it is possible that you have your old project developed with JUnit 4 that you would like to convert to JUnit 5. You just you cannot do it just like that in one day or instantly. And for some time, at least for some time, you may mix the JUnit 4 tests with the JUnit 5 tests. And for this, we would like to have different names for the annotations so that JUnit 4 and JUnit 5 may live together at least for some while. Okay, about tests, we have discussed about the importance of having tests, about the advantages, about the effects, that we can easily add the new functionality, that we are driven by goals. But one important and natural question that arises is, how can we determine that we have good tests? What tells us that we have good tests? Where may we find a metric that will tell us that we have good tests? And a first metric is called code coverage. It tells us to which degree we have covered the source code with our tests. So if we have some code that is written for 10,000 lines, and if we have only 1,000 lines that are checked by the tests that will not be of big help. Only 10% to have a code coverage of only 10%. This is a metric. This is not an absolute metric. It will not, if we have a very high code coverage, it will not make sure that our code is bug-free, but it is a need. You need to have some good code coverage in order to have good tests and in order to have some safety. We have here a few code coverage tools that are popular into the Java world, and probably the mostly used and for our demonstration has been chosen this Jacoco Java code coverage, one of the tools that we are going to demonstrate. You may ask yourself, as I was saying, if you have 10% of the code coverage as our result, it's not good. What code coverage should we have in order to have some safety, to say we are safe enough? And which code coverage percentage is feasible? How high can we bring the code coverage? 80%, would that be good? Maybe. 90% would be better, but is it feasible? You may ask, may I arrive to write tests the way that we arrive to 90%? Or even the ideal situation, may we arrive to 100% of code coverage? This is ideal, but generally not touchable. What I can tell you from my experience is that 90% is not only feasible, but it may be even a part of the definition of done. So your customer will come and say, if you want me to check this task as done, as implemented, you have to have the code coverage of at least 90%. Otherwise, it's not good. So it is not only generally feasible, but also a must and maybe a requirement from the end user, from the customer. 100%, this is really, really hard to make it. This is not so easily feasible, but you may keep it in mind. Even if you cannot touch it at times, you may keep it in mind and try to get as close as possible. So something between 90% and 100% should be really feasible with the goal in mind to arrive to 100% or as close as possible. And we have, however, some bad news besides this. 100 code coverage does not mean that your code works perfectly. Oh, is it like this? Yes, it is. It is. Why? You may, I have tested. It is 100%. Why am I not sure that my code is really cool and it is working perfectly? What stops me from taking this conclusion? The answer is that you may not have some certainty that your tests are really high quality. You have 100% or maybe something very close of code coverage means that your execution passes by there. You execute this and this and this, but maybe what you are checking is not the perfect thing. Maybe you are checking and you are looking for a wrong result. It is possible. Can you have even better certainty about the quality of your code? Okay, we have agreed that 100% code coverage is not enough. Yes, you may have better understanding of the quality of the code if you work with integration testing and if you do some other types of testing that will make you sure that test quality is high. We don't talk about them here, but just keep these things in mind. 100% code coverage or something close to it may not be enough. Your code may not work perfectly, but it is a must. Anyway, high code coverage is a must. Now we have seen that JUnit 5 requires Java 8 or higher. The question is, what IDEs, what tools may I use in order to work with JUnit 5? The answer is that the best IDE that has integration with JUnit 5 is IntelliJ. Eclipse does not have full support yet. So if you would like to start a project with JUnit 5, your first clear option should be your team must work with IntelliJ IDEA. What do you need? You need to have this third-party library, this third-party framework that is JUnit 5 to work with your code. You need some dependencies, and here, if you are working with Maven, you see these dependencies. You need to introduce this org JUnit.Jupyter, JUnit Jupyter API, and org JUnit Jupyter engine dependencies. At least these ones are needed in order to make your code work with JUnit 5. Which other changes have been made by comparison to JUnit 4 at the level of the API? The test annotation now may work on methods and on class and methods that are package private and the methods that are not public. This is something like a marker interface. This test, it will tell to the framework, to the JUnit framework, that yes, this method needs to be considered when you execute this method and check that it is doing this and that. And we have introduced the annotations. We have presented the fact that there are new annotations, and we have explained why we have changed the names of the JUnit 4 annotations when making the step to JUnit 5. We have instead before class, after class. We have now before all, after all. Instead of before and after, we have before each and after each. And this is some demonstration of how these ones look. We are going to briefly see them in action, because we have ended now the presentation, and we move to the practical demonstration. Please allow me just a few moments to switch to the practical demonstration. You please write to me if my screen, and you should see now some document and some ID if it is to be seen. Okay, great. Just a moment, I'll take some water because I have spoken. Okay, so we have the practical demonstration. We have an application, of course, that we would like to show what it is doing. It is already using some tests, but we would like to take the best benefits of what JUnit 5 is providing. Let's see what this application is doing. Let's familiarize ourselves a little with what this application is doing. So we say that we have some program that is providing credit offers to customers. We have our bank or some financial enterprise that is providing credits, and we have two types of credits, and we have two types of customers. Which types? So we have a credit offer that may be economy or business, and we have usual customers and VIP customers. And we keep our customers assigned to credit. They may apply, we may add them to some offers, or we may remove them to some offers. And the bank is keeping some policies for these offers. We say here, we would like to add the customers to some credit offer. If the credit offer is economy, okay, approve request means that this offer is available for everyone. If the customer is VIP, and if the credit offer is not economy, meaning it is business, you have to look at the fact that the customer is VIP or not. If it is VIP, you approve, otherwise reject. So we have some particular credit offers, meaning the business one, that only a VIP can be added to them. This is the policy for adding the customer for a particular credit offer. And there is also a policy for removing a customer from an offer. So we add you, but we may also remove you. And we ask ourselves, may we remove the customer from the credit offer? If the customer is VIP, no, we reject the request of removing, so we protect these types of customers, and we don't want to bother them. We keep them on the list of the offers. If the customer is not VIP, okay, you may remove the customer from this credit offer. And you see here some initial design of the application, some classes. We have some credit offer. We have economy credit offer, business credit offer, and we have these methods of adding a customer and removing a customer to a credit offer. Let's have a look at our code now. So we have this credit offer. See, here you see it's an abstract class. It has two abstract methods, add customer and remove customer. This means that we have delegated the implementation of these methods at the level of the subclasses. We see here add customer to any economy is okay. If you want to remove customer from economy, you have to follow this policy. Otherwise, for business credit offer, you can add only a VIP, and once added, you cannot remove a VIP. This is our business logic. Let's look at how our application looks now from the point of view of testing. We have a look here. What we should briefly understand here, this is the POM of the Maven. We have here we have the dependencies. Okay, and we have some plugin for Jacoco, for Java code coverage. We were saying that we would like to measure the code coverage. Code coverage of what? Code coverage of tests. So we have here 1, 2, 3, 4 tests. So why 4 tests? Because we have 2 credit offers, economy and business, and 2 customers, usual customer and VIP. And if you would like to take a look, say here, test economy credit offer usual customer, test economy credit offer VIP customer, test business credit offer usual customer, test business credit offer VIP customer. We have some significant names. We have some significant names, and the names of the methods are telling us we would like to test this, or we would like to test that. We have some understanding of what it is happening. But even if we are using JUnit 5, we have seen that we have JUnit 5 here into the POM. We are with the philosophy at the level of JUnit 4. We'll show how to make the move. Just for now to run I think I have only one test. Let me run the whole class. Okay, what we see here, we have the 4 tests that have been executed. Everything is green. Would like to have some code coverage. Let me check it. So we go from here to the folder where we have our application. We write mdn test. Let's wait just a few seconds. Okay, so we have run our tests and we are asking ourselves, what's the code coverage? We have to go here to target site Jacoco and open this report. Let's see what's here. Oh, we have 100%. So if we go here and we see that our tests have passed inside all the code. So we see here with green, 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 everything has been executed. So we have a good application. We have a good testing application. I was saying that this is not absolutely sure that it is fully bug-free, but it is at least a premise. We have 100%, but we would like to do more. We would like to show how to use the facilities of JUnit 5. I'm going back here, and we have a new look here at our tests, and we see here we have test for tests, and we may think about the fact that we can add tests, and we need to hard code what we are doing and to look here, test that or test that. Do we have a better alternatives? Yes, with JUnit 5, yes. And we have here some tasks that we are going to show. Says that we have to redesign the existing test to use the hierarchy of annotated classes and tests. We will be able to keep a test into a test, to construct a test hierarchy. We are told here which the names of the test should be, how to annotate them, and we would like to keep this hierarchy and to be able to have this very significant story about what it is done, what it is checked. Let's follow what we are told here. So we should work on multi-level testing classes. Top-level classes bank test, yes, that already exists, but what does not exist is the fact that it has two nested test classes, economy credit offer test and business credit offer test. Let's go here. So right here, public class. And we need to annotate it with nested. Okay. And we also need to have business credit offer test. Public class. And of course, nested. So we have a separation of concerns. Into this class, we are going to test what's related to the economy credit, and here what's related to the business. Let's see the guidance. Each of these two ones should contain two new tested classes, usual customer and VIP customer. Let's do that. And we have the same here. Well, what we should understand here that we have 1, 2, 3, 4 classes at the bottom level, and here we are expecting to have one test for each of them to make things hierarchical and easier to understand. Okay, what we need here, we would like to make some replacement. We see here that we have a credit offer customer Mike. We may ask what is the credit offer economy? Oh, it is at the level of this one. And here we may also have John. And we may label these things like private. Okay, private. Private. And inside these two classes, we need to write some testing. So we need to have this test method, public void test. We are just calling it like this. And we simply take this from here. What if we execute only this method at this time? Just to make sure that we are going the right way. Oh, looking pretty well, but we haven't shown yet everything that is possible. We can take this customer and insert here because it is only needed inside this usual customer class. And we can take this customer, which is a VIP, and write it here and say test. I will just copy the signature of this. And the logic is the same from here. Great. So if we would like now to follow what's happening, we may much easier read. We have an economy credit offer, and for a usual customer, we are testing this. And if we have an economy credit offer, and for a VIP customer, we are testing this. Let's see what we can do more. We have here some indication that we haven't applied yet. Says here we should use this display name annotation. Let's see what it has here. Display name. I will write here, given, I'm following, in fact, given there is a economy, we are at economy, given there is an economy credit offer, given there is an economy credit offer. Okay, what when we have a VIP customer or when we have a usual customer, okay. Display name. When we have a usual customer, and here when we have a VIP customer, what should happen in this case? Then you can you can add him but cannot remove him from an economy credit offer. Then you can add and remove him from an economy credit offer. Let's write like this. So display name. So we have usual customer. Then you can add and remove him from an economy offer. And on the other test, then you can add but cannot remove him from an economy offer. So you see how we are documenting our application, explaining in fact the scenario. Let's just execute this class again, only this class, subclass. Well, so we are able to read in plain text, in plain English, or if you prefer some other language, what our application is supposed to do, and I'm reading here. Given there is an economy credit offer, when we have a VIP customer, then you can add, but cannot remove him from an economy offer. Given there is an economy credit offer, when we have a usual customer, then you can add and remove him from an economy offer. Wouldn't you say that it is looking much better than if we execute this? It says test business credit offer usual customer. This has a pretty good name, but it is hard coded and it still remains at the level of one method. We have seen how it was looking like. It was telling us the full story. What is given? So you have this and that. Then you do that. When you do that, then you are expecting something to happen. So this is really great feature. We label our, not only that we have this significant hierarchy, but we can also label our tests. So nice that we can immediately understand what it is happening. This is in the spirit of documenting the application. Okay, great. Let's add the second class, business credit offer test. I will take a look here and I will label it. Given there is a business credit offer, okay, what do we have? When we have a usual customer, yes, we have the same, but for a business offer. Or when we have a VIP customer. Okay, great. What are we expecting? We still need to write, of course, this test method. So we have a business credit offer and the usual customer. Let's have the look here. We have a business credit. We'll need to add some variables, of course, but I will just do this. So we need to have this business credit offer and this customer mic. We have this business credit offer, which is known at the level of the business credit offer class. And let's make it private. And we have mic, which is our usual customer. and it should be known only here. We have one more test for a VIP customer. We have John. Let's make it VIP customer here. Private. And the method test. What are we testing? We are testing that we write this in display name. Display name. So we have a VIP customer and a business credit offer. What is the storytelling? You can add him but cannot remove him from a business credit offer. Then you can add him but cannot remove him from a business credit offer. And here, usual customer business offer. Then you cannot add him to the business credit offer. Well, seems that we have made the step here. Let's execute only this for now. And we read in plain English. Given there is a business credit offer, when we have a VIP customer, then you can add him but cannot remove him from a business credit offer. Given there is a business credit offer, when we have a usual customer, then you cannot add him to the business credit offer. So you see plain English. You immediately understand what your application is supposed to do. As we consider that we have translated these tests, of course, they were very, very useful because we had here the logic that showed what to test. But we have improved the design, the internal design of the tests, because, of course, we are taking advantage of these new facilities of Java 5. Let's run now for the first time the full bank test. We have independently run economy credit offer test and business credit offer tests. Everything is green, and I invite you to take a few moments to see now and to read what it is doing, what it has tried to do, and what it has obtained, this time in full plain English, fully understandable human language. Okay, it seems that we have translated our tests with using of JUnit 5. Is there anything that we should do? Yes, we still have a thing to do. Remember about our metric, about our code coverage metric. Let's try to see if we have really kept that 100%. We were here and we are running MVN test. Let's wait a little bit. Okay. Let's look here. That was the file with the report. We can open it in browser. We have remained at this 100%. So not only that we have translated our code, our tests to use the new benefits of JUnit 5, but we have kept the same quality as much as we can make some quantification of the quality. I was saying that even 100% may not be enough. But from this point of view, at least, we have also kept the quality of our tests. And if we look here, let's have a look again. I remind you how you can read and understand what our application is really doing by reading plain English. So this concludes our demonstration, and we're still open for answering questions, for explaining, providing more explanations. We have touched all our goals for the presentation. We have discussed about TDD, about JUnit 5, what's the need, what's the philosophy, what the JUnit 5 provides in addition to JUnit 4. We have explained that there are changes not only in API, but there are changes at the level of the architecture and philosophy. We have shown how to migrate some tests to take full advantage of the JUnit 5 new API and new facilities. So we have touched all our goals for today. We are still open for questions. So please, I'm here to go ahead in written form and would try to answer your questions.
Okay. Thank you very much, Catalin. So guys, we have around 10 minutes left for our Q&A session. So if you have any questions, please type them in the chat box on your right panel. So if you have any questions for Catalin.
We have a question here saying, is TDD good only for unit testing? Test-driven development refers mostly to unit testing. So we would like to test at the level of units. And by units, we understand mainly a method or a class. If you would like to make a step forward, there are some other concepts, but they all rely on this TDD. So they come on top. You see here, have the picture. Just a moment. This picture you see that JUnit, I was saying that JUnit and unit testing and TDD are at the ground of this pyramid. What it means is that on top of this TDD, we may come with other things. We may come with integration testing, but it is also on top of TDD, and very much alike in our present day world, we may think about what is called BDD, behavior-driven development. So when you think about BDD, you will not think mainly at the level of class method, but you will think at the level of the behavior of the customer or of the end user. And we have tried to simulate here only with the JUnit 5 this behavior. The keywords from behavior-driven development are given when then. There are frameworks like Cucumber or JBehave that really deal with the whole stuff. Here we just simulated this. If you arrive at to conclude to the answer to your question, if you arrive at the level of integration testing or behavior-driven development, you will still rely on the main concepts of TDD. In fact, this behavior-driven development has been first thought as an improvement, as an extension of TDD. It comes on top of it. And if the TDD is making sure that we are doing the thing right, so that we are getting the expected result, BDD comes and says, you are doing the right thing, not only the thing right, but the right thing. So your application really has business value, and this is what the end user is trying to have. And this is the really business valuable feature that you will add, the feature that is satisfying this scenario or this user story.
Okay, thank you, Catalin. Any other questions? Okay, so it seems these are all the questions for today's webinar. Catalin, thank you very much for your presentation. Thank you everyone for taking part. You will be receiving tomorrow an email with a feedback form, which we would love for you to complete just to make sure that we improve our future webinars. And we also invite you to subscribe to our newsletter to be up to date with the latest events. And also we will contact you as soon as we have the video for this webinar uploaded to our YouTube channel. So thank you everyone. Have a great day and see you at our next webinar.
Thank you for attending.